Hi and welcome to Geeks for Geeks. Today we would be discussing a really very interesting question, which is shuffle integers. So before we move forward, first let us talk about the most important feedback of this problem. The solution for this problem is non-intuitive. You don't really have an intuitive based solution rather than an observation which is absolutely very small, and it won't make sense to you if you are an intermediate or a beginner. Okay, this is the first step. The very next learning you can get out of this problem is, if you were not able to deduce the solution from your pen and paper, you would realize that investing more than an hour or 30 minutes does not make sense. Okay, because you are in the wrong direction. So the learning that I want to tell you is that what you can do is, if you see up a problem, you keep hustling over it until you have a direction to move. If for 15 minutes you are blank, turn up to the hint section and then you would have a direction. Okay, so kindly do this. Don't just take a problem and just think over that problem for the next one day. This is not a thing, and only DSA is not required for interviews. Other aspects excluding DSA are also important. So this is the small learning that I wanted to just punch in at this point of time. Now let us just move back to the context that we were here for. So the problem is pretty easy to say. We are given an even sized array. So we are given an even sized array. Let's say 1, 2, 3, 4. What they want is, let's say this is the array, and at all times the size of the array, that is n, it would be even. This is given. N modulo 2 would be equal to 0. This just means this. So what they want is, they want you to think that this array is divided in between, and what they want is the first element of the first array, and the next element should be the first element of the second array, and this third element should be the second element of the first array, and the second element of the fourth array. Let's just have it again. Okay, let's just have it again with some more. Okay, 1, 2, 3, 4, 5, 6, 7, 8. We need to divide the array and think that these two are different arrays. This is, let's say, array A, and this is, let's say, array B. What they want is first element of the first array accompanied by first element of the second array, then the second element of the first array, and the second element of the second array, third element, third, and then 7, then 4, and then we have something like 8. So you might have guessed, but let me just tell you, the numbers are contiguous. This is not mandatory. The numbers can be random and they don't follow a sorted ordering. The sorted ordering and contiguous is maintained in the sample test cases or visualization to make you realize that how so on earth this array is being formed. Okay, so the numbers can be random and they can be in any order. Okay, this is given. Now you don't really have a direction to move forward. You try to think that yes, I would have kind of 2-pointer thing. Okay, I would have a 2-pointer. The very first solution, this just gives me to the very first solution. I would go to the very first point, that is this one, and go to nth by 2, and then I would have the very first element, then this element. After taking that element, I would move forward the pointer. Okay, then we have 2, then we have 6, then we move forward the pointer, and then we have 3, then we have 7, then we move forward the pointer to something like this, then we move forward the pointer, 3, 7, this would be 4 and 8. After this has exhausted, so we are at n. So we need an auxiliary space, okay, to form this. So time we are iterating on each element exactly once. So time complexity would be big O of n, and the space complexity is also big O of n, because we are using an auxiliary data structure. Okay. Let's say now your interviewer is telling you that how on earth you can do this without using any auxiliary data structure. So if I'm not allowed to use an auxiliary data structure, I'm left with variables, because variables contribute constant to the time space complexity. मतलब जितने भी variables define कर लो, time complexity में वो constant ही contribute करेगी. If you didn't knew, now you know. Okay. So now I would try to think in terms of variables. You can do that on a pen and paper. After you have a bigger array, let's say you just take 1, 2, 3, 4, 6, 7, 8, 9, 10, you would come to the conclusion that this is not possible, or this is becoming highly complex. Okay. So now this part is not intuitive. Like this transition from this point to the current solution is not intuitive. You need to keep this in mind. The only intuition you have is to notice that the array elements are less than equal to 10 to the power 3. This is the only small thing, because generally the elements are less than equal to 9 or 10 to the power 18 or something, but here the element size is less. So if you are a very keen observer or a very sharp observer, you would be able to have this conclusion. Other than that, if you are a regular programmer like me, you won't really come to this. Okay, so now the solution is that we just use the given array. Like we have 1, 2, 3, 4, 5, 6, 7 and 8. Now let's just talk about the number 10 to the power 3. The number can be, the constraints is from 1 till less than equal to a of I would be less than equal to 10 to the power 3. What is basically 10 to the power 3? 10 to the power 3 just implies that the 2 raised to the power is how much? Like if you raise to the power 2 raised to the power 10 is 1024. Okay, 10 to the power 3 is how much? 1000. So 1024 is nothing but 2 till 10 to the power 10 at max. So you know that to store this elements, like if there are 32 bits, okay, like 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Let's say the first 5, okay. So if you observe, let's say these are 32 blocks. This is 32 block. So the last 10 blocks would be used to store the number. What do I meant by this? Like if you, let's say we have like something 1, 2, 3, 4, 5, 6, 7, let's say. So less than 8. Less than 8 means 2 to the power 3. So to store all this in the binary form, only the last 3 bits would be used. Like 1 can be represented something like 1. This can be represented like 10. This can be represented like 11. This can be represented like 100. This can be 5 can be represented as 1001. This can be represented as 110. This can be represented as 111. I just meant this. So to store a value less than 2 to the power 3, we would be only using the last 3 bits. Okay, last 3 bits. Other than this, you won't ever require. So if the given number is less than 2 to less than equal to less than 2 to the power 10, then you know that only the first 10 blocks is used. Now let's just see what I meant to say really. Let's say we have 1, we have 2, we have 3, we have 4, we have 5, we have 6, and we have 7. Let's just take 6. Okay, as of now, let's just say that the elements would be less than 8, which just implies that the elements would be less than 2 to the power 3. Okay, so just like in reality it is 2 to the power 10, but we would take here 2 to the power 3, and in this would be replaced with how much? Let me just tell you that also. This would be replaced by, let me just tell you, the original one is that less than equal to 1000, and this is less than equal to 2 to the power 10. But for simplicity, we are taking less than 8 and 2 to the power 3 to just showcase you. Now, let's just say that there are 6 blocks. 1, 2, 3, 4, let's just have 6, okay? Let's just have 6. Let's say this is 1, 2, 3, 4, 5, and 6. So we have 6 blocks. Okay. So we know that to store numbers less than 8, we only need the last 3 blocks. So we would require 1, 1, 0, 1, 1, 1, 0, 0. We would require 1, 0, 1, and we would require 1, 1, 0. So what we would do is we would store the auxiliary thing. We would store the auxiliary thing in the first 3, like last 3 blocks is used. So we would store the first 3 blocks here. So now we know that this needs to be, like, I want to merge which numbers? I want to merge 1 with 4. So what I would do is, I would say C4, 1, you use this block, and 4, you kindly use this block. So 4 would say, okay, just have me here. Give me this block. And by doing this, at this position, you would be storing 1, 4 by using, like, you would be able to store 2 variables in a single position. Okay, like combination of 1 and 4 can be stored in this format. But how on earth we are doing this? Let me just tell you that also. Let's say we want to store 1 and 4. So what we would do is, we would first have 1. That is, the representation is this. Let's say we say that this element would take the first 3 blocks. This element would take, 4 would take the next 3 block. Okay. Now what I want to do is 4. So I want the representation to be something like this. And what I would do is, I would add zeros here. Let me just have this in different color to show you how am I having the zeros. I would have zeros here. And now if I do a OR, I simply do a OR between them. That would result something like this: 1, 1, and 0, 0, 1. And if you observe, the first three bit is 1 and the last 3 bit is 4. Again, how we would be retrieving x and y, that is another task. But as of now, just understand how we are keeping x and y. Now, how we can add zeros in the end. So, if we write 1, 0, 0, left shift by 3, it would be simply 1, 0, 0, and in the end 3 values would be added, which is nothing but 4 left shift by 3. So we can say that x OR with y left shift by 3. This is how we would be storing the combination of x and y. Store x and y. This is how we would be storing x and y, by doing left shift. So let's just first store x and y everywhere. So 4, this would be stored as 1, 0, 0. This would be 0, 0, 1. So let's just have everything again. So this would be 1, 0, 0. And this would be 0, 0, 1. This would be the value. This value would be 0, 1, 0 and 5. What is the binary representation of 5? 5's binary representation is 4 plus 1. That is 1, 0, 1. So 1, 0, 1. 3's representation is how much? First we would be storing 3. That is 1, 1. And we would add here 0. So let's just have here 3 and 6. We want to store that. 3's binary representation is 1, 1. And we would have 0. And the next number is 6. Which is how much? 4 and 2. So 1, 1, 0. Okay. 1, 1, 0. So now this is 3 and 6. This is 2 and 5. This is 1 and 4. This is how we would be having. Now the task is to retrieve the value. How we can retrieve the value. So now let's say from this number I want to retrieve 1 and 4. Okay. I want to retrieve 1 and 4. Okay. So what I would do is I need simply the last 3 bits and all other bits are useless to me. So what I would just say is, so if I want to retrieve the last 3 bits, this is 1, 0, 0, 0, 0, 1. This is how you do problem solving. So if I have something like this, okay, if I have something like this, like let's say this is 1, 1, 1 and rest these all are zeros and I do an AND operation with this. So this would result in 1, this would result in 0, this would result in 0, 0, 0, 0. And this is what? This was this element, that is 1. So this is how we are getting x. So we can retrieve this x. Let's retrieve something more. Let's say we want to retrieve this value. Okay, 2 and 5. So 5 was 1, 0, 1. 4 plus 1. Okay. So 1, 0, 1, 0, 1, 0. 1, 0, 1, 0, 1, 0. 1, 0, 1, 0, 1, 0. Let's say I want to retrieve the last 3 bits. So what I can do is, I can simply do a AND with 1, 1, 1 and these all values would be different. And if I do, I would be able to retrieve, if I do a AND with something like this, this would be 1, this would be 0, this would be 0, 0, 0, 0. And we have the value that is 2. So we are able to retrieve x. But how on earth we would have this value? This is nothing but 2 to the power, like how many ones we want. If we want 2 ones, this is, what is the represent, like what is this? 2 to the power 0, that is 1. 1 plus 2 to the power 1, that is 2. 2 to the power 2, that is 4. So this value is nothing but 7. 7 is what? 7 is 2 to the power 3 minus 1. So number of ones we want in the binary representation, let's say we want something like 1, 2, 3, 4. This is nothing but 2 to the power 4 minus 1. What is 2 to the power 4 minus 1? 16 minus 1 is equals to 15 and the binary representation of 15 is 2 to the power 0 plus 2 to the power 1, 2 to the power 2, 2 to the power 3. Is this value equal to 15? Yes, this value should be equal to 15. 2 to the power 3, 8. 8 plus 2 to the 4 plus 2 plus 1, which is equals to 7 plus 8 is equals to 15. See, we are having this value. So this value can be generated by this. This is a simple idea, like it is used a lot in bit manipulation. Okay, just see all the small ideas. So we got the value of x. if we want the same values as y, what we can really do is we can just left shift by 3, like 1 0 1 0 1 0 1 0 1 0 1 0 1 0 1. This was 1 0 1 0 1 0 0 1 0. Getting the y is easier, so we can just left shift by 3 and we would have something like 1 0 1. Everything has right shift by 3. So by doing right shift by 3, we are having the value of y. And now we can start putting up x and y. So we have all the combinations of x and y at this point. And now we can just retrieve the result. How we can retrieve the result? The very first one was to have AND with 2 to the power this minus 1. Okay, and this would be done. 2 to the power 3 minus 1. We would just do an AND with this and we would have x. To get y, we would simply do left shift by 3. So now we have x and y. Now where to put x and y? We need to start putting up x and y. So now I can retrieve the value of x and y 3 and 6. So what I would really do is I would start putting elements in the back. Why not in the front? Because if I put in the front, then this value would be erased. Why? Because 1 and 4 needs to be kept at this point. Here I would write 1, here I would write 4. So this value is lost. This value is lost. So to have a cunning implementation, we would have from the back, because these all elements are not important to us. The values that holds the data are this side, the left hand side, not on the right hand side. So we would start putting up elements on the right hand side. So on the right hand side, we have 3 and 6. So we would write here 3, we would write here 6 from n minus 2, and we would go here. So we would point at the half. So we would start from the half and we would go to the front. So now we would start from this. We would have x and y. We would have x and y. Again, we would have this value. We would put up x and y. Again, we would have this value. We would put up x and we would put up y. This is how we are doing from the back. Now let's move to the implementation, and this would make more sense. I'm a very lazy person, would be replacing the ARR with A, and now we would be starting off. So we just need to go till the middle element. Okay, so because for int I is equals to 0, I is less than n by 2 and I plus plus, and that value would be A of I is equals to A of I left shift by 10. Like 3 should be replaced by 10. Okay, so we are moving everything on this side, and now I would do a OR to keep that value on that side. So I would do A of I is equals to A of I or with A of I plus n divided by 2. Okay, so now first one move to the these are the two blocks. This is the first n bit, this is the last n bit. First that value moved to this value and this block is empty. Now we do an OR, so this block would be filled. Okay, this is done. Now we would have a pointer to the last element, because we would start putting up elements in the last. For int I is equals to n minus 1. Then we would start from the last. Okay, I showed you, I made a diagram like this and started moving on the right. So for int I is equals to middle minus 1. Okay, that is n divided by 2 minus 1. I is greater than equal to 0 and I minus minus. At this point, we will first retrieve the x. X is equals to A of I. We would do a AND with how much? 2 raised to the power 10. 2 raised to the power 10. 2 raised to the power 10. 2 raised to the power 10 minus 1. Okay. So now to raise 2 to the power 10, a simpler, easy technique is, this is again a small learning, 1 left shift by 10. This is equal to 2 raised to the power 10. Okay. Now we would retrieve the y. Y is equals to A right shift by 10. Like the first, so I told just move this block outside. Now this block is remaining, so this block was that element. So we are having x and y. Now we are able to retrieve x and y. So we would keep that element in the end. A of j is equals to x. A of j minus 1 would be y. A of j minus 1 would be y. And j minus 2 is equals to, like, two elements are done. So now we would move here. That is it. And now let's just compare and see how many errors are we making. Now you were this long for this video. Let me be honest with you. When I solved this problem, like, it has been years since I'm coding and it has been years since I'm teaching. Okay, being a little bit intermediate at programming, I saw that I'm not able to think of a solution intuitively. So I took it by ego and I didn't see the solution for an entire day, and I kept thinking until and unless I realized that I earlier thought that this problem is of graph, then I thought DSU, and then in the end, when I saw the small constraint, I came to the conclusion that this problem is of bit manipulation. So it took me a lot of time to solve this problem. This is not intuitive. So when I solved this problem, this is a completely different direction. So that's it for today. Thank you and have a nice day.